Hello, Professor. I'm Li Changshin. This is my Coursework 2 search engine tool. I'll show the core features, code design, test results, experimental results, Git history, and my reflection on using Jane AI. This project implements web crawling, inverted indexing, query retrieval, and a command line interface. To keep the demo fast, I'll use build 1, which crawls 10 pages but does not update the index file. Now I'll start the interactive CLI. You can see the available commands listed here. These include build, load, print, find, and some helper commands. First, I'll run build 1. This command crawls the website and builds the index, but only for 10 pages. This is just to keep the video demo quick. The crawler still keeps the 6-second politeness window and try mechanism, which still follows the coursework requirements. After building, the system saves the index to dataindex.json. Here you can see the number of pages crawled, number of unique words, and save path. This shows that build completes crawling, inverted indexing, and index persistence. If I use build 1, this does not update the index file. It is only for demonstration. Next, I'll run load. This command loads the saved index from the file system. This shows the index can be saved and restored without crawling again. Now I'll use printgood to inspect one term in the inverted index. The output shows document frequency, term frequency in each document, and term positions. Next, I'll demonstrate find good friends. This command supports multi-word queries and uses Boolean and retrieval by default. That means only pages containing all query terms will be returned. This matches the coursework specification for the find command. I added some usability improvements. Pressing enter on an empty line shows a hint to type help. I also added an optional ranking mode. It can rank results using TF-IDF or BM25. This is an extra feature beyond the core requirements. I also added some usability improvements. Unknown commands also show a clear message. This helps users avoid getting lost during interaction. Next, I'll briefly explain the code design. Main.py is the entry point of the whole project. It parses command line arguments and starts the interactive CLI. Here you can see how commands like build, load, print, and find are dispatched to different modules. This shows the entry logic is clear and users can complete the full workflow from the command line. The crawler is implemented in crawler.py. It uses requests and beautiful soup. It handles temporary network errors using session, http, and retry. I set a 6-second politeness window to meet the coursework requirement. I also added exception handling and retry logic to improve crawler stability. The search logic is in search.py. Find implements Boolean retrieval, while find_ranked implements ranked retrieval. I also added catching to improve performance for repeated queries. The indexer is implemented in indexer.py. It builds an inverted index that records which documents each term appears in, along with frequency and position. I normalize words to lowercase so the search is case insensitive. So good and good are treated as the same term. Overall, the data structures and query flow have clear separation of responsibilities. In the README, I documented installation, usage, and testing. This lets others reproduce the full workflow easily. That includes build, load, print, and find. Then here is the testing section. I wrote unit and interaction tests covering the CLI, crawler, indexing, and search logic. The tests were added incrementally during development. I also added edge case tests and mock tests. I also tested error and empty input cases for load, print, and find, such as missing index, missing arguments, and unknown commands. At the same time, I used mocked tests to verify key flows like crawler retries, command branches, and index saving loading. This is the coverage result. The main.py coverage reached 94%. I also ran benchmark and relevance evaluation. The results are saved in the results folder. The related automation scripts are in the scripts folder. This helps me evaluate retrieval quality and performance more systematically. Here is the Git history. The commits show an incremental development workflow. The project was completed in stages. First the core features, then tests and refactoring, and finally documentation and demo improvements. For Gen AI, I used ChatGPT and GitHub Copilot during development. They helped me understand beautiful soup and requests more quickly, but I use them as development assistants, not as tools to directly generate final code. They also helped me think about test structure, retry logic, and refactoring. However, I also found that generated suggestions did not always fully match the coursework specification. For example, during the early design of the search logic, I suggested combining ranked retrieval directly into the find command, while the coursework actually required Boolean retrieval behavior. As a result, I redesigned the responsibilities of find and find_ranked rather than directly accepting the generated solution. I also noticed that generated tests tended to focus mainly on standard functionality while missing important edge cases, such as politeness timing, empty queries, and invalid commands. Therefore, I later added these tests manually and reviewed the overall interaction logic more carefully. This process showed me that Gen AI is useful for assistance, but understanding and validating the code independently is still essential. That's all for my video. Thank you.